Okay, so the implicit differentiation. What is implicit differentiation? This comes from the different ways that a variable can be function of another variable. So if we have, for example, y equal to a formula in terms of x, in this case, we say that y is a function of x, but the way it is defined, sometimes you hear that explicitly given by the formula, defined explicitly. That is how we have, what are the functions that we have so far, but there are functions in which we don't have explicit formula of x on one side, y on the other side. So y equals a formula in terms of x is explicitly, but we may have cases that y is a function of x defined, this is the word implicitly, by an equation. Meaning what? Meaning that we are going to have an equation in x and y. And for example, let's say x squared plus y squared equals to 1. For different values of x, when you plug in different values of x, for example, when x is equal to 0, then you plug in x there, you notice that it is 1 squared plus, 0 squared, plus y squared equals to 1. And then from there, you see that you have y squared equals to 1. And then you can try to solve it, and you see that y is either going to be plus 1 or minus 1. So this is not a regular function that we know, but we can make sense of something called implicitly defined. And that is how x and y are related to each other. To find value of the variable y, we plug in a value of x, you get an equation, you try to solve it, and then find value of the y, how that dependency is given. Now, so when you have a function given explicitly, you know how to find the derivative of y with respect to x. You differentiate it. We learned all the steps that we wanted, we needed to know. You differentiate. But when it is implicit differentiation, implicitly defined, you need to use what is called implicit differentiation. There are two main things that are different. One is that in the explicit one, you have y equal a formula only in terms of x. In the implicitly defined, you have an equation in x and y. In the explicit case, you have one differentiation rule, and you apply it to that formula. In the implicit differentiation, you cannot do that. What you do, you start doing these steps. It's called implicit differentiation. Step one is that differentiate, this is an equation. I have an equation. Differentiate both sides of equation with respect to x. Well, for example, like the one you have up there, I will try to do an example of that. D dx of x squared plus y squared equals to d dx of 1. Then step two is that, okay, I know, before I go to step two, I know how to differentiate. There are sums of two things, okay? So this will be derivative of a first one plus derivative of a second one. And then derivative of one is zero. Here, I notice that derivative of x squared with respect to x, I know it is 2x. But what is the derivative of y squared with respect to x? That's where you need to have step two in mind while differentiating terms involving y. You use chain rule. Meaning what? Okay, so back to our example, e.g., d dx of x squared is just 2x. But when you have derivative of y squared with respect to x, it's not x squared differentiate with respect to x, or it's not y squared differentiating with respect to y. These are, this is different variable than that. So what you do here, since we already know that that's a function of x, is you apply the chain rule, or in this specific case, generalized power rule. Derivative of y squared is not 2y, it is 2y prime y. Okay, you differentiated an equation, you got an equation all the time. This is what step three, sometimes I write step 3 and 4, but I will just write one step for this last two things. You have now an equation for y prime. You see, there is an equality. There are terms in x and y, but you have y prime there. Sorry, you have y prime. Solve that for y prime. So in other words, the equation obtained in step 1 and 2 needs to be solved for y prime. In other words, let's separate y prime. So in our example, what we have is, I take, this has no y prime, I take it to the other side. So 2y prime y is equal to negative 2x. Then 2 times y is the coefficient of y prime. I can divide it to the other side. And then you can simplify maybe here. And that's what you get. And these are the steps you need to do for implicit differentiation. First, differentiate both sides of the equation with respect to x. While you're differentiating terms with y, you have to know that you're applying chain rule, and then solve that equation for y